Hello everyone, today we would be discussing Codeforces round 923. There were 7 problems and I was able to solve all 7 within the time limit. So I would be discussing like what I did in the contest, like and like that's pretty much the agenda of stream. Before I get started, can anyone confirm if audio and everything is fine? Okay, thanks Shivam, thanks Rajiv. So let's get started for the today's. First problem says make it white. You have a horizontal strip of n cell. Each cell is either white or black. You can choose a continuous segment of cell once and paint them all white. After this action, all the black cells in this segment will become white and white ones will remain white. What is the minimum length of segment that needs to be painted white in order for all the n cells to become white? So like the problem statement says like we have one segment and that segment has n points, like n cells. Some cells are white, some cells are black, and what we can do is in one go we can select a continuous segment of set, and we can paint everything white over there. If everything is already white, then we are just repainting it and doing nothing, but we can do that. And if a cell is black, then it would be changed to a white color over there. And what we have been asked is like, what is the minimum number of cells required so that everything on those cells becomes white? And like now, if we look at the examples, first example, what we can see is like first cell is white, then black, white, black, white. So as you can see, like the first answer is like the answer is always possible because we can always paint the complete segment and make them white. So if you see over here, like what we can do is like we can avoid painting the first cell because it's already white and paint everything from the right side. And even for the last cell, like we can avoid first and last cell which are white, and then we can paint rest of the cells white. So the answer would be 4 over here. And like to give some example on the whiteboard, so like for example, if we take the first example, the first example says white, black, black, although the color does not matches with what I am doing. Like the answer is possible because we can always take all of these cells and mark them white. So it's in fact possible to make everything white. And now if we look at the example over here, like what we have to do is like since like first cell is white, we can ignore painting it. And since the last cell is white, we can also ignore painting it. And like we have to print at least this segment, like because we can paint only once. And we have to paint only once, then we have to find the first place where a black cell exists, last place where a black cell exists. And if we can find both of these, then we can choose them as the starting point. So, and because these are the first and last cell, so all the cells which are painted between them will also be painted white. There may exist some black cells, some white cell, but that was the idea. And like the corner case over here would be like when everything is white over here. In that case, we don't have to print anything in the first operation, and we can print 0 there. So like that was the idea which I have been following. Like one other way would be like we take the complete string, we see like if the last cell is white, we remove it. Like in this case, like what we can start, like let's take some more example over here. What we can do is like we can first check like if the last cell is white, then we can just delete it. If then look at find the answer for the remaining string. That if even the last cell is white, we can just delete it again, and we can try to find the answer for the remaining string. Then the last cell is again white, so we can delete it and try to find the answer. Once the last cell becomes black, like the case can be either this way, the string will become empty. In that case, we can print 0. And if the last cell becomes black, then we reverse the string. Then the string would become black, black, white, black, black, white, white. Because when we are painting a continuous segment, it doesn't really matter if we are solving it for the given string or for the reverse of the given string. The answer will always be same. And then we can repeat the previous process again. Last cell is white, deleted. Last cell is white, deleted. And at last, what we would be remaining with the string which contains the first cell as black and the last cell as black. And in that case, we can print the length of the remaining string we have. And like this was a bit easier to implement because we don't have to maintain two index, or like we have to iterate from the first and right. Yeah, like this is essentially the pointer idea only. Yes, it's placing, you are right. We can also do the pointer and j minus I plus 1. Here in case of maintaining the pointer, I just kept deleting the character. So like, and I will probably jump onto the code which I implemented, and then we will move to the next problem. So the idea, like what I did was, as long as the string is not empty and the last character is white, remove that character, reverse the string, and then repeat again. As long as the string is not empty and the last character is white, remove it, and at last print the character. So like that was the idea for it. Like if there are some questions on here, I can take them. Otherwise, I will move to the next problem. Okay, next problem. Thanks, Prabal. So the next problem says following the string. It says polycap lost the string s of length n consists of lowercase Latin letters, but he still has its trace. The trace of a string s is an array of n integers, where ai is the number of index j which are less than I, such that si is equal to sj. For example, the trace of the string abracadabra is the array 0, 0, 1, 2, something like that. We will see like how it works. Given the trace of a string, we have to find any string from which it could have been obtained. The string should consist only of lowercase Latin letters a to z. And like we are given some constraints, but the most important constraint is like it is also guaranteed that the trace, for the given trace, there exists at least one suitable string which we would be able to print it. So like there is no case of printing -1, no, yes, something like that over here. Let's see like how does the trace of abracadabra is the given array. So like to find the trace for the first character, like the number of characters which are equal to a before this character is 0, so the value is 0. The number of b's before this character is 0, so the value here is 0. The number of r before this one is 0, so like we have trace e1 0. And if we count the number of a's before this character, then we have one such a, so the value for the trace over here is 1. If we count the number of c's before this character, there is no c before it, so it's 0 again. If we count the number of a's before this one, like there are two such characters, so the value here would be 2. If we count the number of d before it, like there is no d before it, so the trace here would be 0. If we count the number of a before it, there are 3 such a's. So the trace of value over here would be 4. If we count the number of b's before this one, like there is only one b over here, so the trace value here over here would be 1. If we count the number of r before it, like there is only one r over here, so the trace here is 1. And if we again count the number of a before it, it's 1, 2, 3, 4, so there would be 4 a before it. And like this array, if you can verify, matches the given array 0 0 0 1 0 2 0 3 1 1 4. Like probably looks like I messed up the character over here. A 1A 2A 3A. So like this value should be 3. Like I ended up counting the same character. And now what we are given is like one idea to create a constructive problem is you come up with an idea, then you try to solve something, try to find some answer on it, and then instead of asking that idea, you say like this is the answer given to you, find the problem for it. And like that's how some people create constructive problems. Here in this case also, like the first author took a string, he defined a trace on it, and then he said like I am giving you some trace, now you have to find the string for it, the reverse part over here. So like now in the test cases, we are given that we are given a string and we have to find the trace for it. So like if you look at this example again, right, so you will notice that all the places where a exists forms some increasing sequence. Like when the first a happens, the value is 0. When the second a happens, the value is 1. When the third a happens, value is 2. When the fourth a comes, the value is 3. When the fifth a comes, the value is 4. So like what we can do is like we can find a continuous sequence of elements. For example, 0, 1, 2, 3, 4, and we can assign all of them the same character. Like because we can print any string, instead of a we can also print z. And we ignore these indexes, then now we try to find the next character again. Like we can find, like for example, 1 exists this. So we can find 1 and 1 0, we can print the same character over there. It can be B, C, anything over there. And this would work fine. And like the other way would be like we start from the first character and we maintain a frequency table of all the characters. So initially, like all the characters would appear 0 times. And we know that, like for example, we are given some trace. And let's say the value is 5 over here. Then some character, like if you look at the number of times all the characters appear in this range, at least one character would be there where the value would be 4. Because we are given that the answer always exists for the given string. So what we can do is we can try to find any such character and we can paste that character over here. Let's say the answer we have created so far contains this as an array. One, 4, 5, 2, 4. A, B, C, D, E, and so on. Then over here, like we can either choose A or we can either choose B. Any of them will work because like we are essentially swapping the values over here. Like if we put B over here, then for the next 5 we would end up choosing E or some other characters. And if we choose E over here, then we always have a choice to put B whenever next 5 appears over here. And we can print anything. Like it's not saying that we should print lexicographically smallest. So like that was the idea for this problem for me. And like I will try to jump to the code which I wrote for this one. So my idea was I first took the array as input and I am maintaining a frequency table like which is up to n, but you can also create it of length 26. While creating, I did not realize it. Now I iterate over the given character and I try to find any character where the frequency is equal to C, because like that would be the character which I can pick like for the next time. If frequency is not equal to IC, otherwise like now I would be taking ith character. So I increase the frequency of like the number of times ith character appears by 1, and then I add ith character to the given string and break over here, and at last I am printing the given string. So like any questions on this one? So like that was one idea to do this problem. How do I make the frequency table? So the idea was like I am maintaining all the characters which I am putting so far. So I start with like initially I will have an empty string. And we know that the number of times all the characters appear in this string is 0. Now when I have a trace C, I try to find any character which has appeared so far on. Like the part is recursive over here. Like when I add a new character to this string, I increase the number of times that character appears by 1. So for example, if the trace is C, I find any character which has appeared C times so far. Then I take that character. Yeah, you can put it into the map as well. Like I was using vector, but yeah, you can put it into map and it will work as just as fine. And then now I try to add that character to the backup string, and instead of computing or everything again, I am increasing that character by 1. Because if you know, like if you take this string like of length I minus 1, and if you add a new character at the back of string, then like then you know that if you look at the number of times each character appears this string, then the character which appears here will increase by 1. Like we can even put it into the map and use ASCII value. Like I can show you around like how to do that. No, we are putting C because like C is given to us in the given array. No, like C was the variable I was using to iterate. And I am using C because it's given that by the definition of trace that you have to pick the character which has appeared C times before it. Like C was the character, you can call it some AI as well. That should work fine. So like that was the idea. Okay, like it says the trace of the string S is an array of an integers where AI is equal to number of indexes J such that SI is SJ. And like because I was iterating, so I was calling it C. You can call it AI as well. So like that was the idea. So I will try to move to the next problem then. Choose the different ones. Here it says we are given no, the reason for choosing no is not because it has appeared like this is the code for the map. Is not because it has appeared the maximum times. The reason for choosing it is like because we are given that as the value over here. If it says AI value is C, then the number of times one particular character, we can pick any character which has appeared C times in the string from 0 to I minus 1. Like instead of C, I can also replace it with AI and call it. It says choose the different ones. Given an array of n integer, an array B of m integers, and an even integer k. Your task is to determine whether it is possible to choose exactly k by 2 elements from both the arrays in such a way that among the chosen one, every element from 1 to k is included. For example, it says like if A is 2, 3, 8, 5, 6, 5, and B is 1, 3, 4, 10, 5, and K is 6, then it is possible to choose values 2, 3, and 6 from array A. Like 2, 3, and 6 from the array A, and elements with value 1, 4, 5 from the array B. 1, 4, and 5. In this case, all the numbers from 1 to k equal to 6 will be included among the chosen elements. And then it says if the array is A is 2, 3, 4, 5, 6, 5, and B is 1, 3, 8, 10, 5, and k equal to 6, then it is not possible to choose elements in the required way. Like the one way to see it is like 1 appears over here, 2 appears over here, 3 appears in both of them. Like let me just write it on a paper here. If the array is 2, 3, 8, 5, 6, 5, and B is 1, 3, 4, 10, 5, and if k is 6, then we have to choose 3 numbers from both the arrays. And one way to do it would be like we choose 1 from here, we choose 2 from here, we choose 3 from here, we choose 4 from here, 5 from here. Wait 1 second. One way to do it would be we choose 1 from here, 2 from here, 3, 4, 5, 6, and we are done with it. While if we look at the other possible example given to us, 2, 3, 4, 5, 6, 5, A is same, but the B is 1, 3, 8, 10, 3. Then you can see that 1 appears only in this array, 2 appears only in this array, 3 appears in both of them, 4, 5, 6 appears only in them. So like we are forced to pick 4 elements from the first array because they appear only in the first array. Like 3 can be chosen from any of them. So like there is no way we can choose 3 numbers from both of them and get numbers from 1 to 6. Because 2, 4, 5, and 6 are the 4 numbers that appear only in one of the array. And like that was the main idea for the same problem. Like for all the characters from 1 to k, we count whether like we can divide it into 4 categories. It does not appears in A, it does not appears in B. In this case, the answer is no. It appears in A, it does not appears in B, then some question mark. Like we must choose it from A. It does not appears in B, but it appears in B. So then we must and it appears in both of them. Then we are flexible to choose. Now the way to approach this problem is you first check characters from 1 to k and see like if it appears in any one of them. And if it does not appears in any of them, then we directly print no, like it's not possible to choose it. Otherwise, we count the number of characters of this type. And let's call it C1. We also count the number of characters of this type, like let's call this CA and CB. CA are the characters that appear only in A and are between 1 to k. So for CA number of characters, we have no choice but to choose them from A. And similarly, CB are the numbers from 1 to k which appear only in B. So in that case, we have no choice but to choose them from B. So the next step would be like we choose these numbers first, and then we look at the difference of k by 2 minus CA and k by 2 minus CB. And because all the remaining numbers appear in both of them, we can choose any of this number of characters from A and any of these numbers from B. We have to choose k by 2 characters from both of them. So the idea is like if a particular number from 1 to k does not appears in any of them, then we can never choose the k different numbers from them. And if there are more than n by 2 numbers which appear only in A, then we can never choose all of them, because we would be able to choose only n by 2 numbers from A, and the remaining numbers which appear only in A will not be present in B. And the other case when B has n by 2 characters which appear only in B and does not appear in A. So in that case, the answer would be no as well. And if both of those are values are less than n by 2, like there are n by 2 numbers which appear only in A, and n by sorry, I am getting a bit confused. So if there are k by 2 numbers which appear only in K, and if there are k by 2 numbers which appear only in B, then we can first choose those numbers from A and B. And for the remaining numbers, because they appear in both the arrays, we can choose any from A part and any from the B part. To summarize the approach again, we have numbers from 1 to K. Like for each number, there are 4 possible cases. They does not appear in both A and B. Like for each number over here. In that case, the answer is no. They appear only in A. Then in that case, we have no choice but to choose that number only from A. They appear only from B. In that case, we do not have any choice. We will have to choose that number from B. And they appear in both A and B. So we are flexible to choose it from any of them. So the idea is if any number is of first type, print no. Otherwise, count the number of the characters, count the numbers which are only in A. And we have to choose it from A. So let's first pick them from A. Then we look at the numbers which appear only in B, and like we choose them from B. And if so far we have picked less than k by 2 numbers from both of them, then the remaining numbers which we need appear in both of them. So we can choose any from them. Now its place is giving me an example 1, 3, 5, 9, and B is 2, 3, 6, 7, 8, and K is 6 then. Like 3 is in both of them. Like first, let's just ignore the numbers which are and K is 6. So which are greater than 6, like we will never choose them. 3 is in both of them. Let's choose it at last. If we look at 1 is only here, 4 is only here, 5 is only here. So let's choose these numbers from A first. And if we look at 2 and 6, like 2 is only here, 6 is only here. So let's pick this from here as well. So now we have chosen 3 numbers from A, which would be 1, 4, 5. We have chosen 2 numbers from B, 2 and 6. And 3 is the last number we need, and it's in both of them. So we can choose 3 from here. And the answer would be yes in this case. So like that was the idea for it. Like I can jump on to the my code as well in case there are no doubts over here. So like I will try to simplify my code a bit. Let's make it 0 index. Now we can, or we can do it the other way as well. I'm using the zero base indexing for the numbers. Then choose B as well. If the number is at least in one of the array, otherwise possible is false. Like let's keep it simple. Now let's count the numbers which appear only in A. Present in A, but not present in B. If there are more than k by 2 numbers which appear only in A, then possible is false. And if there are more than k by 2 numbers which are in B, then possible is false again. LLI is the short form for long int. LLI equal to long int. And like, let me just submit it, like it's taking too much time. I think it will compile. Let me just go ahead and submit the code which I have written so far. Present A, present B. Okay, yeah, right. This should be A. Why runtime error? Okay, yeah, I forgot to check. Like, we should make present only when the numbers are less than k. Like, we can ignore the numbers which are greater than k. Yeah, that was the idea. Like, to summarize the approach once again before I move on to the next problem. Like, I have created two vectors present in A, the numbers present in B. I have kept the length K because we do not care about the numbers which are greater than K. We will never pick them. So first take the input of K. If the number is greater than K, ignore it. Otherwise, reducing by 1 to have 0 base indexing. Present in A true. Similarly, present in B true. Now we see possible. If the number iterate from the numbers x equal to 0 to K. If the number is present in either A, then present in, or the either B, then there would be some way to choose this number. So we continue it for now. Otherwise, we say that the answer is not possible. Now we iterate again from the numbers from 1 to K. We count the numbers which are only in A. So present in A is true, present in B is false, and increase their counter by plus 1 by 1. And the numbers which are not present in A but present in B, then we increase the counter of B by 2. If they are more than K by 2 numbers which are only in A, then we will not be able to pick K by 2 numbers from A and other numbers from B. Because if you see, the remaining numbers in B would be less than. Similarly, if there are if the number of numbers which are only in B is more than K by 2, then the answer will not be possible. And now if possible is to print yes, otherwise no. Any questions on this one before we move to the next problem? Like, this is pretty much the full code. Like, everything else is template over here. The main code starts from here. And I can send link in the chat. So like, this was the idea. And now I will move to the next problem. It says find different ones. You are given an array of n integers and q queries. Each query is represented by two integers L to R. Your task is to find for each query two indexes I and j, or determine that they do not exist, such that I is in this range, j is in this range, and the value at I is not equal to value at j. In other words, for each query, you need to find a pair of different elements among AL to AR, or report that such a pair does not exist. And like, let's take some of the example first. For the problem C, like 1 1 2 1 1. Then what we can see is, like, first query says 1 to 5. So it asks us to find the two index in this complete range that have different values. And as we can see, the values possible here are 1 and 2 only. So we will have to choose this two as one of the index. And like, we can choose I equal to 3, and we can choose any j which is equal to 1, 2, 4, or 5. Next query says 1 to 2. And if we look at the numbers in 1 to 2, both of them are 1. So like, we will not be able to choose two different numbers from this range. So we should print answer -1. And in the third example, it says we should pick two index from 1 to 3. So the problem is same. Like, we will have to pick this two for sure, and we can pick any one of them. Like, we can say like either I equal to 3 and j equal to 1 or 2. So like, yes, this is one index array in the problem D, at least in the problem statement. And like, I can try to run it on the next sample as well. Like if first query says 1 to 2, and there are only two numbers from 1 to 2 and both of them are different. So we can just print I equal to 1 and j equal to 2. Second query is 2 to 3, and both the numbers in 2 to 3 are equal. So we should print -1, -1. Third query says 2 to 4. And there are two different numbers over here, 10 and 20. So we can choose like I equal to 2 or 3 and j equal to 4. And similarly, we can try to solve the other queries. So any questions on the problem statement itself before I try to jump on the solution for this problem? So like I will probably jump to the solution for it. Like let's say we are given a fixed value of r and the array looks like this. AR is somewhere over here. And let's try to find the values of L where the answer would be possible and the values of L where the answer is not possible. Where answer is impossible. Then from the previous ideas, what we know is that answer is impossible if all the values in the array are equal. So the idea would be like we start from AR and we see check if AR -1 is equal to AR. If yes, then we say that the answer is impossible. Like there would be some range like this where all values in this case, if the given L is chosen in this range, then the answer is no. Otherwise, the first value would be different from AR. Like if we try to show it again in the different example. If this number is not equal to 5, not equal to 5, and if this is the AR, then if we choose L this, the answer would be no. If we choose L this, the answer would be no. If we choose this, the answer is no. And when we choose this, we will have two different values. We can choose I as this and J as any of the value over here. And now even if we, let's say we have been asked to find the answer for this part, we can still choose these two numbers like this index and this index. And like that was my main idea. Like for each index, I found the number which is not equal to that number and the largest L possible over there. And then at last I checked if like the first time a different number appears from the given R is before L or not. If it was, so like now the algorithmic part, choose J equal to R and I equal to largest index less than R such that AI is not equal to R. AR. So now if the left part is before this index, then we can choose this index and R. And if the left part is after this index, we will know that all the numbers in this range are equal. So the answer would be no. Yeah, battery I will add. Yeah, like that is the main idea. It's plus we iterate back from the R and choose the largest number which is not equal to AR. And now the problem is like it can get TLE. So we will have to do some smart way to do the same thing. Like it's plus what you have written would give you correct answer, but can get TLE because like the time taken would be very high. So now we will have to figure out some smart way to do it. So like, so the next part is like, let's say we have given array A1, A2, A3, A4, A5, A6, so on. Let's say we are at AL and we want to find the largest index. And here, let's say we know that AK is not equal to AL and all the numbers in this range are equal to AL. Now what we can do is we can check if AL plus 1 is equal to AL, then the largest index where this would be equal to would be AK. Else if AL and AL plus 1 are not equal, then the largest index where we will find a different number is AL itself. And that's how we would be able to find the largest index which is not equal to current index in the given range. And once we know that, like we can use that to queries as well. Why am I only checking the left side of AR? Because I have to choose from AL to AR, right? So either I have to check on the left side of AR or I have to check on the right side of AL. I can do the same part for the right side of AL as well. And the only reason I did this was because I knew if I can do it with, if the answer exists, then we can do it with AR itself. Yeah, Rajiv, you are right as well. Like the similar solution for an index of next greater element and next smaller element. And if both of them are different, then we can do, and like the main idea was mostly that will also work for you. No, you can say it's a kind of DP because I am reusing the previous answer over here. Okay, to summarize again, like what I have said is like I have numbers from A1 to AN. I choose J as R, J equal to R, and I start from R, check R minus 1, R minus 2, R minus 3, and so on. Either I will reach L or I will find a number which is not equal to AR. In that case, I can choose the index which I have found as I and I can print those numbers. And if while running this loop, I go up to L minus 1, then I can print minus 1, minus 1. And now when I have this algorithm, what I am saying is like instead of repeating it every time, I can pre-compute all the values for all the values of R first time when I will find the different numbers. And if I do not find any such number, I can just say that the different number exists at minus 1 or something like that. And now the idea was like if we have AR equal to 5 and if all the numbers are 5 and then a number not equal to 5 appears, then all the ranges which are in green, the answer would be no. Or for the range in R, like there would be two different numbers. We can choose the number which is not equal to 5 and we can choose R. And now if we are to find the answer in blue range, like you can reuse the answer which you have printed for the red range, because those are the two different values of I and J where AI is not equal to AJ. So like once you know the answer for red, you can also find the answer for any range which is bigger than it. So like the main idea was find the first number if you start from R, move backward, which would not be equal to AR. And what I am saying is like to find that number, now we can pre-compute it. So let's say we have number from we have some a, like we know like the previous number which is not equal to them until here, and now we want to find the answer for ak plus 1. Then there can be two cases. Either ak is equal to ak plus 1, or ak is not equal to ak plus 1. If this not equal to is the case, then we can choose I equal to k and j equal to k plus 1. So the previous number which is not equal to ak plus 1 is ak itself. And if ak is equal to ak plus 1, then we can reuse the previous value which was not equal to ak. And now I can try to show the code. I am using zero based indexing, and I am maintaining the previous value which is not equal to given index in the given vector. Like for 0, like there is only one value, so previous value would be 0. I start from 1, and current value is ai. If current value is equal to ai minus 1, then reuse the value which you have found for I minus 1. Otherwise, we call that this value is not equal to I minus 1. And now this is how I am finding the largest index which is not equal to current index and exists before it. And once I know this part, I am solving queries. I take L and R. If everything in range from L to R is equal, in that case, like the previous value which is not equal to AR is greater than equal to L, then I can print the previous value of R and R. Since it's zero based indexing, so I am adding +1 again over here. Otherwise, I am printing -1 over here. So like any questions on this part before I try to move to the next problem? So I will move to the next problem. It says Klever permutation. So it says we are given two integers n and k would be less than equal to n. I remember earlier it was k less than n. Yeah, when I solved this problem. A permutation of length n is an array consisting of n distinct integers from 1 to n in any order. Like it's the definition of permutation. For example, 2, 3, 1, 5, 4 is a permutation, but 1, 2, 2 is not a permutation because 2 appears 2 times in this array. And 0, 1, 2 is not a permutation because for n equal to 3, 3 is not present in this array. And they are asking us to print a k level permutation of the length n. And they have also defined like a permutation is called k level if among all the sum of continuous segments of length k, of which there are exactly n minus k plus 1, any two differs by no more than 1. Formally, to determine if the permutation is k level, we construct a new array S of length n minus k plus 1, where the element Si is sum of index from I to I plus k minus 1. And a permutation is called k level if maximum value in S and minimum value in S is less than equal to 1. And it says find any k level permutation of length n. Now let's look at the examples given to us as well. And like one important thing, it says like it under the given constraints, it's guaranteed that such a permutation exists. So like we don't have to think whether the answer is impossible or not. Like let's pick one of the sample over here. Like I am taking third sample where n is 10, k is 4. 8, 3, 10, 1, 7, 4, 9, 2, 6, 5. So like we have to repeatedly find the sum of four numbers over here. Sum of these four numbers you can see is 22. Sum of these four numbers is 21. The sum of these four numbers is 10, 1, 7, 4. It's again 22. Sum of next four numbers, this is 21. And similarly, we can try to find the next part. Sum of these four numbers would be 22. Sum of these four numbers is 21. And sum of these four numbers will be again 22, I believe. Yes, 22. So you have got an array 22, 21, 22, 21, 22, 21, 22. And you can see that the maximum value in this array and minimum value in this array's difference is 1. So any questions on the problem statement, like what it is asking to us, like before I try to solve this problem? So now moving to the solution for this problem, like one way is like we have to print any possible we can find over here. So what I tried to do here was, like if we look at the given array, then if we check, like the first k numbers would be sum of these, and the next k numbers would be sum of these. So the difference in these parts is difference of pk plus 1 minus p1. Similarly, if you try to take the next part, difference between consecutive two part would be pk plus 2 minus p2. And now this gives you an idea, like you should try to pick in the ranges of k. So what I did was p1, p2, p3. Let's say, like, let's assume that n divides k for now. And what I will try to do is I will try to find one answer where the difference would be 0. Like I am writing the numbers over here. Here it would be p n by k minus 1 into k plus 1 p n by k minus 1 into k plus 2, so on until p n by k into k. Like I am assuming that k divides n. We will solve the other cases later. Now what I did was, I started adding 1 over here, 2 over here, 3 over here, so on until n by k. Then I did the reverse part, n by k plus 1, n by k plus 2, so on until 2 into n by k. And now if we look at it, you will see that we have filled two numbers over here and sum in each segment is equal. Then I start with the next number over here. 2 into n by k plus 1, 2 into n by k plus 2, until I go 3 into n by k. Now I start from 3 into n by k plus 1, 3 into n by k plus 2, and so on until 4 into n by k. And like when I am filling two numbers at a time, and for each row the sum of numbers is equal. Like here, like it's 1 plus 2 into n by k, sum is same. Here it's 2, and here it's 2 into n by k minus 1, so on. And even if you compare the range of continuous ranges, the difference is always 1. Like the difference in this and the difference in this part would be 2 minus 1, which is 1, and so on. And here, so like that was the main idea. And like now I can extend it even to range, further range, where like some of the half rows will be filled. And what you can verify is like it will satisfy the given constraints as well. And pretty much that was the idea for this problem. I can show code for this one. The main way to solve this problem was to come up with some idea which will work and then see it works over here. I start with reminder r equal to 0 to r less than k. Current values which I want to fill over here. I make jumps of k, and if r is odd, reverse the range. Yeah, good question. Why k even? Like at least what I saw was like when I'm following this algorithm, I am filling two numbers at a time. So if k is even, my solution works. But if k is odd, like at last I will have some numbers where I won't be fill two numbers at a time. And this solution will definitely not work. And I think probably the problem setter also had the similar ideas where he was filling two numbers at a time. So he ended up saying like he knows the answer for k even, print the answer for even only. If you are able to solve it for k odd, it's good, but I don't need it. And like that was like this is the code. If I am filling the even part, then I am reversing the numbers. Or I can try to create two arrays at a time and increment r in the ranges of 2 over here. That will also work. And then I also made an assert check to verify if my answer was correct. Although when I submitted, I commented it out. Like this was the algorithm to check it. So like any questions on this one before I move on to the next part? Like the next problem will be relatively hard. Like it was requiring some MST over here, minimum spanning tree. And it was a DP problem, G problem. So like although the number of ACs say otherwise, like I felt like this contest was relatively harder than the previous Div 3 I did. So if there are no questions, then I will move to problem F. Okay, I will move to problem F now. Okay, so like I will answer that as well. Like given an undirected graph with n vertices and m edges, there is at most one edge between each pair of vertices in the graph, and the graph does not contain loop edges from a tree vertex to itself. The graph is not necessarily connected. A cycle in the graph is called simple if it does not pass through same vertex twice and does not contain same edge twice. Find any simple cycle in the graph which is the weight of the lightest edge is minimal. So like the problem statement is very short and sweet. Like it introduces a formal definition of graph and everything. It says you are given a graph, there are m edges in this graph and each edge has some weight. Look at all the possible cycles in this graph which does not have same edge two times, which does not have same vertex two times, and look at the weight of minimum possible weight of an edge in that cycle. And among all the cycles, you print any cycle which has minimum weight over here. Like if let's say there are three cycles which have weight 444 minimum possible, then you can print any of them. But if there is only one cycle which has weight 4, then you should print only that cycle over here. And now the output, it's asking us to print the minimum edge of weight, and then it's also asking us to print the cycle which we have formed. And it also says under the given constraint, the answer always exists, because it says like if the number of edges are greater than n minus 1, then the graph definitely has at least one cycle. We can take a look at sample as well. Like in the first sample is no fun. Like second sample is a bit interesting. 1 to 2 there is an edge of weight 10. 2 to 3 there is an edge of weight 8. 3 to 1 there is an edge of weight 5. Now we have an edge from 4 to 5 which has weight 100. Wait, okay, 1 second. 5 to 6 has weight 40 and 6 to 4 has weight 3. So you can see like in this graph there are only two edges, only two cycles, and in this cycle the minimum weight is 5, and in this cycle the minimum weight is 3. So we should print this cycle as an answer. And similarly there are more examples as well. Now like I was trying to find in my stream like one problem which similarly I have solved before, and I thought of just copying the solution from that, but because I have coded the same problem before, like at least some ideas for this problem. So now my idea is like we can run the algorithm similarly for finding maximum spanning tree. Like note that I am finding maximum spanning tree instead of minimum spanning tree. And the algorithm to find minimum spanning tree is generally happens is sort all the edges in decreasing weight. Note in minimum spanning tree we sort them in increasing order of the weight and then iterate on them. For a particular edge u, v and w, you check if u and v are connected. If they are, then you ignore the edge. Otherwise, you add edge and connect u and v. And at last, you take the sum of all the edges which you have taken so far. So now if we notice this algorithm, you will see that at last you have a tree or forest if the graph is not connected. And whenever you ignore an edge, at that point of time, a cycle is forming over there. Because if u and v are connected, then there is some path from u to v. So what I did was I ran this algorithm. I found the last edge which I have ignored. And my claim is, if we find the cycle which contains this edge, then this would be the minimum possible weight among all the cycles. So by running the algorithm for maximum spanning tree, which is just opposite of minimum spanning tree, and if you keep noticing like which all index you are ignoring, then the last time you ignore an edge would be the edge which contains minimum weight and is still present in one of the cycles. And after this, you have one edge which starts from E, which ends at V, has weight W, and you have to find one cycle in the tree you have created which connects both of them. And sin is, I think that's what you are asking. Like, you have found some edge, and how do you find a cycle which contains that edge? And the idea for that is DFS. You can also do BFS, and that will also work over here. Like, you start DFS from one end, you ignore this edge, and you run over here. Okay, Rajiv, good question. Like, why not minimum spanning tree and find the first ignore edge? Like, there is a corner case which I will share. And like, whenever you reach the other end of the node, you can keep track of all the parents you have visited so far and take that as a path from the cycle. And like, doing this will solve this problem for us. Like, there is one more slightly complicated algorithm which I did, and I will share that as well. And like, to answer Rajiv's question, if we start from minimum edge and find the first edge, then I will give you a counter example. Like, let's say first we have added 1 and 2 of weight 4. Then we have added 2 and 3 of weight 5. Then we have added 3 and 4 of weight 6. Then let's say we have added 2 and 7 of weight 7. In this cycle, the minimum edge weight is 8. But let's say now you add 1 and 3 of weight 10. Then this is the cycle which contains an edge of weight 4, and that's minimum possible. And like, what is the proof that my algorithm returns correct? Okay, Getans is saying in F, can't we first remove nodes with degree 1 and keep on doing this, iterate using Q? Then only nodes that will remain are the part of cycle, and W is the weight of remaining. Yes, you are right. That also works. You keep removing weight 1 because like those are the hanging nodes over there. And once you remove them, every node will have degree at least 2. And like, now you can prove that this graph, like every node in this graph has a cycle. So you can take the minimum edge and try to find a cycle in it, and that will also work. So the proof why my solution was working was, like, there is something known as cycle decomposition. And it says like, when we are running the previous algorithm of finding, then all the edges we have ignored, using them we can uniquely find a cycle over there. Like, I hope the name is correct. Like, is this correct? Let me just verify. Okay, not really sure if I can find it, but like I know like one problem which I will try to find. Like you can probably share it. Like it's in somewhere in my DMs. I can add it in the comments. And the main idea was like all the ignored edges would be part of at least one cycle over here. And like the other algorithm which I ran over here was like I was similarly finding like instead of minimum, like you take any spanning tree over here. And like for all the ignored edges, you look at like the path in them. Like for example, this is one spanning tree, spanning forest to be honest. It's not say connected. And now let's say you have this as one of the ignored edge. This as one of the ignored edge. So what I did was I found the weight of minimum weight edge in this path and this cycle. Like this is one possible cycle, take minimum over here and maintain the endpoints. Here also I found the minimum on this path and along with the weight of this edge and took minimum, and like this is one possible cycle. And I tried to iterate on them, and at last I found like one cycle which has the minimum weight, and I know at least one edge in that endpoint. And the next algorithm was finding any cycle which like the cycle in this spanning tree. And like if you want to find, you can do binary lifting, like which the algorithm used to find similar to finding LCA. So will have to maintain two edges. Like when you are doing a jump of length 2 to the power k, you maintain the LCA which is of 2 to the power k, and you also maintain the minimum in that range, and you will be able to recursively find. Like in the screencast, I was trying to find one educational round problem like which involved a similar idea of using LCA to find the minimum. And like I will try to find it after the stream, and if I find it I will add it in the comment section over there. So like these were the two algorithms I had. And like so there are two implementations. Like the simpler one I realized later. Earlier I went with, so like I take all the edges as input, zero based indexing, so reduce the vector, and then sort in the ascending order of weight and then reverse it. Now iterate in the decreasing order. If you take like the present edge u, v, and w, if u and v are in the same edge, minimum edge weight is 12, and like you maintain the endpoints of this edge, source and distance, and continue. If they are not same, merge them and create a tree over here or forest. At last, you print like the edge you have found, and you print a cycle which starts from the source and ends at a destination. And the way to print cycle was DFS. Like you are maintaining one stack of parents which you are on the tree so far. So whenever you encounter a new vertex, push it into the graph. If you reach the destination, just maintain a copy of the current stack. And now continue on the parents. If next value is not equal to p, run a DFS again. And when you are returning back, you pop everything back from the stack. And last, I printed the stack, the copy which I created over here. And like the second solution which I did was, and like the simple reason I did was like I have coded similar things before as well. Maintain all the edges, Now we don't really care about the weight of the edges, although I have sorted them over here. Like it should work without sorting them. Let me see. Does this compiles? Okay, random shuffle definitely doesn't work. But okay. So like here I have sorted them and I have created a similar tree. And whenever I am ignoring, I am keeping track of the weight. So you know that if you are ignoring an edge between U to V, then there exists a path from U to V where all the edges have weight less than the current edge weight. And similarly, I have created a graph. Then I am using some binary lifting, which we will go into details later. And then all the edges which I have ignored, like here I am finding the minimum weight of all the edges in that forest we have. And if it's greater less than equal to the current weight I have, ignore it. Otherwise, mark it as the minimum weight and maintain a copy of source and destination. Print that edge weight and then print the cycle. And for finding the minimum edge weight, I am doing binary lifting. Like, where is it? Like, because it's a forest, so we will have to iterate on all of them. And instead of maintaining visited, I just mark them by height 1. DFS to keep a track of all the parents in the jump 0 for the binary lifting part. And keep continuing it. And then you maintain it for all the log n heights, j equal to 1 to log n. If you want to find it for r, you take a jump of 2 to the power j minus 1. And then you again take a jump of 2 to the power j minus 1. So you will know the parent which is at distance 2 to the power j. And you want to take the minimum on this path, then you can, if when you are taking the jump of 2 to the power j minus 1 and 2 to the power j minus 1, take the minimum distance, minimum weight on that path. And now when you want to find minimum weight between x and y, you run the similar LCA algorithm. Just that whenever you are jumping for LCA, you maintain a pointer which is weight and take minimum with the weight. When I am jumping, I am also taking the weight from the other part. Like this is the algorithm, one algorithm for LCA. You can do other stuff as well. And like that was the second algorithm. And I think the reason random shuffle is not working was like whenever I am creating the as like the current edge can have minimum weight and I can force it, like it would be distributed between multiple edges. So if there are more questions on F, I can take or some other algorithm which you want to discuss. Otherwise, I will move to the last problem. Like although I have one solution for it, like I am a bit skeptical whether that's correct or not, although it passed all the test cases. Okay, I will move to the last problem for today. Paint charges. Again, we have a horizontal strip is given to us. It says in the id cell there is a paint of size AI. There is a paint charge of size AI, using which we can either go to the left and print at max A cell AI cells on the left part, including I, basically this range. Or we can go to the right part and we can print all the cells which are at distance at max less than AI. Basically this part. Obviously, we cannot go outside the boundary 1 or n, or we can decide to not use this paint at all. And what we are given that we cannot notice that we cannot use a paint 2 times. Like we cannot print both left or right. We can either print left or right, or we decide not to use it. And like we can print a cell multiple times if we want, that's fine too. And we are asked like what is the minimum number of times, minimum number of paints we will have to use to print the complete strip from 1 to n. And like there are way too many samples over here. Like I can try to pick one of them. Like for example, in the third sample, it says we can, like third sample is 1, 2, 3. It says like if we pick the paint over here, we would be able to print both the cells. Answer is 1. In the ninth test case, it says like we need only 3 colors. Like from cell 3 to left, like this will print everything on the left part. 5 to left, this will print next to cells. And from 7 to left, this will print the other 2 cells over here. So my algorithm was like I tried to pick one color at a time, moving in the increasing order. Like this definitely involves DP, IJ. DP IJ denotes minimum number of paint we need. Using paints from A1 up to AI, such that we have painted everything from 1 to J. Painting outside J is allowed. So like we have used first I paints and we have colored everything from 1 to J and minimum number of paints required. You are allowed to print extra if you paint extra if you want. So the algorithm was, let's say we have found now let's say like we have found the answer up to DPI. And like for all 1 to n. Then if we do not use the current paint, then the answer remains same. So like DPIK remains, or we will now use the paint AI and see like what all we can do with the paint AI. Like either we can go to the left for each J. Like if we look at the index I, and let's say this is the range we can print. Then for each index in this part, like let's say we want to find the answer over here. Like first I did was like if we go to the left, then we will paint everything over here. So we can take the minimum DP value from the previous part over here and say like and at last we do normalization over here. Like for all the values which are greater than, like the main idea is like we'll know the answers for DP I-1. And then we try to like find for all the exact values, like when we have painted up till I using the color AI by going left. And the idea is once we know this, like we can always normalize by taking the minimum from the remaining part. Like this is a bit vague over here. Like I will show you the code, like exactly what I mean by this part. And the other possible solution from AI is we go to the right. Then also we are using only one paint over here. Like we paint up till this point. And one more hack I did was like when I am at I and I am painting this part, and let's say this is the connected part. So I choose one color from over here as well, which I will use to go to left to connect this part. So like I can simultaneously use one extra color from future, like one extra color from future that will cover left part in future. And like basically this was my painted color so far. I am from I, so although I am moving to right, I chose one intermediate color using which I will go left. And that's how I was choosing two colors at a time over here. And probably I think the DP state I defined earlier is no longer valid over here because I am taking it from future. Or the other way to look at it would be like when we are at I, we take one left part and we take minimum of from this and this range over here. Or when like always we do this way, but we may need some intermediate stages as well where we are going right, going more left. And one state when we are jumping right. Like I'm not really sure why my solution works, but yeah, like that was something was passing sample I submitted, and like at the end of the day it worked. And it might be possible that it got hacked over here. I was taking it as input, like DP states denotes the colors which I have processed so far and the minimum colors I need. Like for everything, the color is infinity. For covering until 0, the weight is 0. Then I'm iterating from index 1 to n. AI is the current index. The left endpoint, right endpoints denotes I go left, what would be the max index? When I go right, what would be the right index? Then this part is relatively simple. Where I am going left, so I will paint up till index. And like I start from all the painted colors from L minus 1 to the index I have and add 1 to it. Right part was tricky. Like one way to paint up to right is you paint up to right, add 1 to all the elements which are from current index up till j. And this was a bit of hack, like where I am choosing two colors at a time. One AJ, like the left index which I will go up to, and then AR was like I am choosing two colors. Like I have painted up to LJ minus 1 from J which is greater than I print left, and from I print right. So now my overall paint is up to R. What the proof I don't have is like why only two colors over here? Like it can be the case that we need 3 color, 4 color, something like that. So like this is a bit skeptical part for it, and like that was pretty much the solution for this one. Okay, can you explain with some example? So now let's assume like I have processed some colors, and like I am maintaining one DPJ which says the minimum colors to paint from 1 to J, such that I have used only colors which are before J. Then like let's say I have some DP values and I have processed up to colors I minus 1. Now I am taking color I, and either I go left, then if I am doing this segment of part, then the already painted part would be this. And I take the minimum possible cost over here. And like if you want me to run on the sample, I can do that as well. Or the other way was, and like the other way was from I to I am going right. So now I have painted up to R. But what I did was I chose one color using which I go left. And I take the minimum value to paint just before it. And the only reason thing I don't have a proof for is like why using only one to the left is enough. Like why don't I choose two such values over here? Like one possible reason might be that let's say we choose two colors and the second color just paints up to this, so we don't need it. Okay, then Nilesh is asking for cycle-based problem in graph. What are general ideas that are using apart from DSU? Like the reason I use DSU is mostly because it's available in Edcoder library and I use Edcoder library a lot. Like probably you might want to look at CP algorithms. And then there is one USAV guide as well. Like there are some things over here, like there is one dedicated topic cycles where they are detecting some part Eulerian cycle something, some LCA as well. And like if you read these two line topics over here, like this would mostly be enough to know at least some beginner ideas which you need as a foundation to start on the problem. And like if you want more, like there is one CP handbook as well. Like these are the resources which are definitely free, and like you can always find more books which you want to read. Like graph algorithm, basic graph, graph transversal, shortest path, tree algorithms, diameter or longest path, binary tree, spanning tree, some directed graphs, strong connectivity, tree queries, paths and circuits, flow and cut, something like that. Not sure if this has a dedicated topic. So solutions of CSS graphs are lengthy, not able to code, give tips. Like the only way you can tackle like the lengthy problems is trying to code more data structures problem. And like for that, like short contests are definitely not the way, like because in short contests you won't find more implementation problem. So like unfortunately Codeforces is not a suitable way to learn the how to code complex problems. Neither is Edcoder beginner contest Edcoder problems, and probably not CodeSurf as well. Like in our time there was long contest, and you can give a shot at universal cup as well. Like these are like mostly these days you will find implementation problem in ICPC type of contest only. So you can try to register here. Like these generally have some 5 hour contests, so you will can definitely find 1 or 2 problems which require a lot of implementation, because these contests are designed for 3 member team to solve in 5 hours. And like Universal Cup can also help you prepare for ICPC as well. So I guess I will probably end my stream now. Like, one thing which I have is no concrete proof like why my solution works over here. Like initially I did not had this hack and like it was failing some samples. When I added it, it passed. I submitted it and it got an like, although I do have some intuition why it should work, but no rigorous proof for it. Although I haven't provided rigorous proof for A, but at least I do see like it should work. So what's your opinion on CSES? Like for CSES, like although I have not solved more than 5 problems there, but like based on the feedback of others, like what I have seen is like it contains the standard problems which you should probably know. And like here they have split it into some sections as well. So like if you are looking to practice some tree problems, you will find many standard problems and you can use it as follow. Okay, when did I become so like this is my graph. Like I started college in July 2017. So it took me around almost a year to start with Codeforces. I was solving CodeChef back then. And if I look at the first time the CM is, then the contest date is around September 2028. Like it was pretty much the third semester. But like what it does not takes into account is like before joining college, I knew at least how to code in C and some basic problems. And I guess I will end today's stream now. Thanks everyone for joining in today.